Good afternoon, everyone. I am Rasineni Kalyani. I am a final year student pursuing computer science engineering at Cambridge Institute of Technology North Campus. Today I am here to present my project on heart disease risk prediction. The main aim of the project is to build a machine learning system to predict whether a patient is having a heart disease or not. Going forward, the process goes on here, where I imported the libraries what and all we want, where pandas is used to load the data and numpy are used for numerical operations. Here I took data set from the Kaggle, which is heart disease risk prediction. df.head is used to print the first 5 rows of the data to know what to understand the structure of the data. Here dataset dot shape, where shape is used to know the number of rows and the number of columns. Where here 918 rows are there and 12 columns are there in my project, in my dataset. df.info, which is used to know the information about the data. Here there are 12 columns. Here there will be like categorical and numerical data set. Age, sex, chest pain type, resting BP, cholesterol, and so on. Age is of type int, like resting BP, cholesterol, fasting BS, resting ECG, and so on. Here the dependent variable is like heart disease. This is the statistical summary. Where here we are calculating the count, mean, standard deviation, minimum and maximum. Here age is age around the 53% average and so on. Most of the people are having heart diseases around the age between 50 to 60, and the cholesterol about 300 above, 200 between 200 to 300, and the BP range above the 120 150 range. Class distribution, like a target here, heart disease, there will be like 2 binary values, 0 and 1, where 1 is indicating who are all having the heart disease and 0 indicating who are not having the heart disease. The count of the heart disease patients are 508, and who are not having the heart disease was 410. This is the count plot for the people who are having the heart disease and the who are not having the heart disease, where here 0 indicates who are not having the heart disease and 1 indicates the person who are having the heart disease. Next, moving on to check the missing values. In my dataset there were no missing values. Here we are converting the categorical columns into numerical columns. The categorical columns are such as index, chest pain type, resting ECG, exercise agena, ST slope, which of the data type of object. We are converting the categorical columns into numerical columns because the machine learning system will not understand the categorical columns, so we are converting into the numerical columns. Moving on to the data visualization, EDA, univariate data. Univariate data analysis was performed to understand the distribution of individual variables such as age, cholesterol, and resting blood pressure using the histograms and the count plots. These are the histogram plots for the age, resting BP, cholesterol, fasting BS, max HR, and cold peak. In distribution of the age, it is showing clearly on around which age people are getting the heart diseases. There, that is around people who are having the age around between 50 to 70 who are having the heart disease more, and whereas it is showing the resting BP and cholesterol. Cholesterol is about between 200 to 400. And moving on, max HR is around between like 120 to 180. Moving on next into multivariate data. Multivariate analysis was carried out to study relation between the multiple target value using box plots and scatter plot, correlation heat maps and pair plots. Next, box plot helps to visualize distribution, median, spread and outer limit of futures across heart disease classes. It clearly shows which future has significant variation between diseased and non-diseased patients. Here it is showing that age around 50 to 60 are having more heart disease people. Next, moving on to the cholesterol and heart disease. Here it is like around between 200 to 300 people who are having the heart diseases more. And next, moving on to the scatter plot. Here it is like on which age, based on the age and cholesterol who are having the heart diseases, where blue is indicating that who are not having the heart diseases, orange color is indicating the person who are having the heart diseases. Around 50 to 60 age people are having more heart diseases, and between 200 to 300 people of cholesterol having the heart diseases. And moving on to the pair plot. Pair plot is used for multi-analysis for visualize relationship between multiple futures simultaneously. It helps identify correlation patterns, class separation and future distributions across heart disease risk classes. And this is the pair plot. Where we can here we can see that people who are having the low max HR plus high volt peak, they are strong indicators of disease. Higher age indicates that they are having more risk to get the heart diseases, and high cholesterol alone not strongly predictive, and heavy overlap in BP, weak suppression. And moving on to the correlation heat map, where here we can see that we are visualizing where futures between all futures, like if we are having one, it is like high risk, strong prediction. Moving on to the 0 who are not having the heart diseases, it is like weak prediction, they are not having heart diseases. Moving on, here like chest pain type around minus 0.39 is strongly linked, and sex males more likely are getting the heart diseases more compared to the female, and age around 50 to 60 they are getting risk increases with age here. And then fasting years, it is correlation around plus 0.27 slightly associated, and the cholesterol minus 0.23 weakly negative. And moving on to the who are not having the weak features, that are resting BP and resting ECG, they are not affecting more. Next we are going to the regression models. They are linear regression, rigid regression and lasso regression. We are coming to the linear regression. I calculated the R square value, it is around 43%. And moving on to the rigid regression, here we are getting value around like 43%. And lasso regression, here we are getting 42 R square, percentage of R square score, and this shows the R square of different regression models like linear regression, rigid regression and lasso regression. And moving on to the convolutional classifications, the first we come into the logistic regression. Here we are calculating accuracy and precision, recall, F1 square and support. For logistic regression, I got percentage around 84%, and this is the confusion matrix where we will be having here. It shows like first true negative, false positive, false negative, and going it into true positive. Like in medical problems, we usually minimize the FN is very important, because false negative is not considering in medical cases, which will cause to the patient death of the patients. This is the confusion matrix for the logistic regression. Here I am getting the accuracy about 70%, and I am calculating precision, recall, FN score, and support, so on. This is the confusion matrix for KNN model, and next we are moving into the decision tree. Here I am getting 79% of accuracy, and as usual I am calculating precision, recall, and so on. This is the confusion matrix of decision tree, and moving on to the random forest. Random forest, this is the 89% accuracy I got, and calculating precision, recall, so on, and this is the confusion matrix for that. And support vector measure, here I am getting 64% of accuracy. And for my project, random forest is the best suitable classification because it handles non-linearity, reduces overfitting, good with mixed features. Neural networks. Moving on to the neural networks. Here I am training the data about 50 epochs I am doing here, and calculating the accuracy. It was like 88% accuracy for neural network. Confusion matrix for that. And next, I plot the neural network accuracy graph where blue color is for training and orange is for validation accuracy. It shows that gradually the training and as well as the validation is increasing gradually, so my model is best suited data set. It is like balanced one, it is good model. And moving on to the deployment of my project, I will show demo of my project. Here first we have to log in by giving the admin. That I am giving all the data to my input for my data, and we are predicting the risk. It is like high risk, about probability about 73%, and I am calculating the showing the model comparison. Here also, as I said before, random forest is best suited for, and it is giving a high accuracy when compared to the different models. And this is of sharp water drop flowchart. Here it is showing why it is getting the high risk based on which features it is getting. Red indicates strongly and blue indicates weakly, where red is like risk that our features are creating like getting the disease more. Here we can generate our PDF report, what we got, and I implemented the AI medical assistant here, chatbot, to know increase this. Yeah, if I say it will assist for us. High risk detected, consult cardiologist immediately, monitor BP daily, reduce cholesterol intake, avoid smoking. This is about my project. Thank you.